Let's go ahead and take a look at the last type of nonlinear function we're going to be dealing with for a while, and that's going to be our square root graphs. So just as before, let's start with an xy table. And we're going to start with 0 just like always. Nice little starting point, where y equals the square root of 0, which is just 0. So we have our ordered pair 0, 0. Let's go ahead and go to the left. Negative 1. Y equals the square root of negative 1. Well, we can't take the square root of negative 1. The square root of negative 1 is a non-real number. The square root of any negative value is a non-real number. So our graph is not going to go to the left at all because all of these x values over here are negative. So our graph is actually only going to move in one direction. It's only going to move to the right. And so we can't do those. So let's go ahead and look at positive 1 instead. Y equals the square root of 1, which is 1. So we have the ordered pair 1, 1. And then we have, let's try 2. Y equals the square root of 2. Well, that's going to be 1.4 something. Okay, that's going to be a decimal value. Recall that the square root of non-perfect squares are going to be irrational numbers. So this number continues forever with no pattern, but we know it's going to be somewhere around this area, but we want to go ahead and find something that's a little bit more precise. So let's think about, well, what number can I take the square root of? Well, I could take the square root of 4. So y equals the square root of 4, which is 2. So now we have the ordered pair 4, 2, which plots here. And we could keep going. Let's think of the next number we can take the square root of. That's going to be 9. Y equals the square root of 9, which equals 3. So we have the ordered pair 9, 3, which is this point over here. And so very similar to our quadratic graph, we see that we have this curve that's taking place, and the next point is getting further and further out as we continue to go up. And so we'll go ahead and plot the graph in this direction, and we have that sideways arch. So all of our square root graphs are going to have this type of an arc shape. So let's see how that compares to this graph that we have here with that arc shape, where it starts and how it continues. So we can graph our equation. We'll start with our xy chart. We have x, and we have y. So we'll start with 0. Y equals 2 times the square root of 0 plus 5. 0 plus 5 is 5. Well, I can't take the square root of 5 and get a nice pretty integer number. So let's choose something else for x that's easier to plot. Well, let's think. If I add a number to 5, I want to get a perfect square. Some perfect squares that I can take the square root of. I can take the square root of 0. I can take the square root of 1. I can take the square root of 4. I can take the square root of 9. Oh, well, I could add 4 to 5, and that would give me 9. So let's use x equals 4. Y equals 2 times the square root of 4 plus 5, which is 2 times the square root of 9, which is 2 times 3, which equals 6. So I have the ordered pair 4, 6. We can start with that one. 4, 6. All right, well, let's think about, okay, I got to 9. How can I get to the square root of 4? Well, what we can do instead is add a negative 1 to 5. That'll give us 4. Y equals 2 times negative 1 plus 5. So 2 times the square root of 4, which is 2 times 2, which equals 4. Negative 1, 4 is one of our points. So we can take negative 1, 4. All right, well, we can keep going. So this one allows us to have a negative x value because we're adding 5 to the number, which gives us something positive that we can take the square root of. And so if we think about that on the other perspective, what is the smallest number I can put in for x that will still give me a non-negative solution? And what that's going to be is what is going to give me a 0? What value of x can I plug in to give me a 0? Well, if x is negative 5, that's about as small as we can go. Let's try negative 5. So y equals 2 times the square root of negative 5 plus 5, which is 0. 2 times 0 equals 0. So we have the point negative 5 comma 0. And if we try to plug in something further to the left, like negative 6, we see that we get negative 6 plus 5, which is the square root of negative 1, which is not a real number again, so we cannot plot that point. And so we see while our arch is a little bit more steep to start, we are still following that same traditional pattern of a radical. And there are our introductory nonlinear functions. You're going to need to be very familiar with these shapes because they will be showing up a lot. You need to have these shapes memorized so that we can apply them in different functions and different patterns in different ways. And knowing the shapes is going to make your life significantly easier as we start manipulating these equations in various ways. So that way you know you have enough points to get the shape that is necessary.